Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate. Now, let's start getting into some of the forms, because we understand that there's certain characteristics of quadratics, and there's actually 3 different forms quadratics can be given to you in, and each form has an advantage. So let's talk about the first form, which is called standard form. So when these are in standard form, notice you have clearly an x squared term, an x or a linear term, and then a constant. Okay, so let's talk about what this means here. So, lost my pencil, there it is. So the a right here in the beginning, this is going to give you your concavity. So if it is positive, remember if something's bigger than 0, it's positive, it's going to be concave up. If it's negative, that means it's less than 0, it's going to be concave down. Okay, now the b term in the standard form does nothing for you. It doesn't give you intercepts, it doesn't give you anything with vertex, nothing. However, this c term will automatically give you the y-intercept. And remember, with y-intercepts, the x-coordinate is always 0, comma, and then whatever this term is right here, that's going to become your y-intercept. So let's look at 2 examples to help us out. So you can see over here, I have 2 examples. So I'm going to turn on, or here's our first example. So f of x equals x squared plus 12x minus 1. Now do you see this is in standard form? So in this particular case, our a is 1 because 1 is the coefficient of x squared. See, right there. B is 12, doesn't help us, and c is negative 1. Now remember, c is going to give us our y-intercept. So if we want the characteristics of this, we already know what the y-intercept is going to be. So we already know the y-intercept is 0, negative 1. Now we know because a1 is positive, it's more than 0, we also know it's going to be concave up. So for standard form, this is about all we can get from it. The rest of what we need, all those other characteristics that we talked about, the x-intercept, the vertex, range, increasing, decreasing, axis of symmetry, all has to come from a picture. So look to the right, here we go. We're going to go to Desmos. I'm going to turn on this graph. And now we can see what this looks like. So we're going to need some key values here. So I'm going to click on the graph and you're going to see some points pop up. So we got to be careful right here because we have 2 different sets of points here. So notice I have 2 points really close to the origin. 0, negative 1 is our y-intercept. But look, we already figured that out. So I'm going to turn that one off. That tells me this other point right here is going to be the x-intercept. So I'm going to zoom out here so I can see it a little bit better. So I'm going to click on that one, and that one. Now, the domain, if you remember, for all quadratics is going to be all real numbers. The domain is always all real numbers for quadratics. Why? Because there are not any numbers you can input into this function that will restrict it. Now let's talk about the range. The range is going to be looking at it from the y-axis. So if you look at my graph here in Desmos, I can see the range is not all real numbers. I can see, if I look along the y-axis, the function exists all the way until about this point here. So my range, the lowest it can go is whatever the y-coordinate is here. And this is my vertex. I could see it's negative 37, comma. Now, the highest it goes, well, if I keep zooming, it doesn't matter. It keeps going all the way up. So we're going to say positive infinity. Now, based on my picture here, what is my vertex? My vertex is negative 6, negative 37. So it is this point I have right in front of here. Now, fun fact, the axis of symmetry is the vertical line that goes through the vertex. So I'm going to use, so it's an x equals, and it's going to be a vertical line that goes through this vertex right here. So if you can imagine a vertical line is going to cut through that vertex, well, what it's going to cut through or go through is the x coordinate. So it is x equals negative 6. So it's the x coordinate of the vertex. So let's think about this. The vertex gives you 2 things. If I know the vertex, I know a part of the range, and I know what the axis of symmetry is. All right, so we have x-intercept, or no, we have y-intercept, x-intercepts, okay? So x-intercept. Well, let's look at our picture here. So we know there's a point here and that point right there. So all we have to do is copy those down. Notice those are rational numbers, meaning they are decimals, okay? So we have both intercepts, we have concavity, we have domain, range, vertex, intercepts. Last but not least, let's talk about increasing or decreasing. So when we look at our picture, we can see to the left side of my vertex, I'm going to turn those off. On the left side here of my vertex, my quadratic is decreasing. So I'm approaching from negative infinity all the way till -6. Now it's increasing on the other side. So from from -6 to positive infinity. Okay, so there are our characteristics. So what you can